Okay, today we're going to talk about chemical reactions, what a reaction is, parts and different components, and we'll get to some other things. So by definition, what a chemical reaction is this. It is the change in the arrangement of atoms. The change in the arrangement of atoms change in the rearrangement of atoms that yields a new substance with different chemical composition and structure composition and properties. Let's go with properties. Than the original. Okay, so like an example is like a campfire, right? You burn the wood, well, there's no way to get that exact composition or structure back because a chemical reaction occurred where we burn that wood. Now it's ash. The big thing I want you to also note here is that they're irreversible. So, changing the arrangement of atoms, yielding a different chemical composition and properties, and they're irreversible. Now, different parts are as follows. Number one, there are reactants. Number two, products. Number three, there's an arrow. That arrow could be from left to right. Okay? It can also look like this, where we have an arrow going in both directions, meaning this reaction is reversible. And then one other thing we could do is we could take the arrow, we put a delta sign above it. Delta means change in. What can that be? It can be change in temperature, volume, or pressure, usually. Those are our three. Then from there we also have a plus sign. So it tells us things are put together, they're added. Another indicator, or another thing we always do, is they're always balanced on both sides. The reactants equals the products. And then the last thing is this. Sometimes you'll see a little S, a little L, or a little G. That tells it if it's a solid, a liquid, or a gas. But this last one is a little more interesting. We may not see it all the time, and it's an AQ. What does that mean? It means it's aqueous. In layman's terms, it means that is dissolved in water. That's what aqueous means, dissolved in water. So let's do an example, and it's an easy example. If I take hydrogen gas, so diatomic hydrogen, H2, and I add to it diatomic oxygen, O2. When you take hydrogen and oxygen, you put them together, you end up making most abundant chemical on the planet, right? Water. Now, so H2O has reactants. The reactants are the hydrogen and the oxygen. Has a product, H2O. It has an arrow, it's going in this direction. We have an addition, meaning hydrogen and oxygen are being put together. We have to balance it. Well, I have two hydrogens, but I have two oxygens and only one oxygen here. So what I do is I put a 2 right there. Now this is distributed, as we learned in class, so 2 times 2 is 4, and 2 times 1 is 2. So therefore, in order to get 4 hydrogens, I put a 2 right there. That gives me 2 times 4 for 4 hydrogens. And I have 2 oxygens. 2 times 1 is 2 oxygens, so we're good. Now, if I wanted to, I could have said this. I could have put a little G here, right? So hydrogen gas and oxygen gas. And then I could have said this makes water, L, which is a liquid. And so I'd have the different components, and here's an example of a chemical reaction. There are 6 major types of reactions or classifications. The first one we'll study are called combustion reactions. you'll like combustion reactions the most. Why? Because these are usually associated with heat and fire. The second one is called a synthesis reaction. It's where we take things and put them together. Next one, decomposition reactions. So what we do is we take things apart. Single replacement. It kind of means what it says. In this type of reaction, we replace a single thing, meaning one. There's also a double replacement, where we replace two things. So a double replacement reaction. And the last one is a specialized type of double replacement. So some people will say there's 5 plus 1. I added in, okay, some people say there's 5. But I think it's good to recognize that acid-base neutralization reactions have some of their own classified properties and make them a little different from other things. And I don't know, but again, this is really just a type of double replacement. So if somebody asks you out there, in the world, how many types of reactions, there are 5. This video is about indicators. What is my indicator that a reaction actually occurred? So, the first one that we are going to see is we are going to see a change, delta, in heat. So that's the first one, a change in heat. Now there are 2 ways in which we could change the heat, okay? 2 terms that we use. The first of which is said to be endothermic. In an endothermic reaction, heat enters the system. In general, what happens in the surroundings, therefore, guys, is it gets colder. So an example of something is endothermic is a refrigerator. How do I remember that? I see endo and enter. Those 2 things to me look pretty similar. The other type is called exothermic. This is the opposite. In this one, heat exits the system. We feel it. Like on a combustion reaction. How do I remember this? Because exit and exo for me are linked. A second indicator that we might see, you might see the production of light. So you can see it. A third indicator that you might see is the making of a solid. So you take 2 liquid things and you put them together, you get a solid, right? We have a term for that. That term is called precipitate. And what it is by definition is, it's a solid formed from liquids. So there's something that precipitates out. A fourth indicator for us is pretty simple. We might just see that the color has changed. So, color change. And the last one, number 5, is production of a gas. Now, how do we know that one happened? Well, we smell it. There's some type of odor that we can smell. Now, we have to be careful with this one because we never want to take, our face and put it in a beaker or put it in an Erlenmeyer flask and be unsafe. But at the same time, we might be able to pick up different odors and know that there was the production of a gas. And those are our indicators, our 5 indicators of a reaction.